Hi everyone, welcome back to the workshop, and it's repair time again, and this time, just like the last video, I've got something a little bit more old school. This is the HP 5300B measuring system, and it was kindly donated by Thomas here in the UK, and it's faulty. But before we go into it, let's take a look and see how this modular test equipment actually goes together. Well, you've got this top unit here, the 5300B display power supply, and you've got these other two units here. I've got a 5304A timer counter and a 5308A 75 megahertz timer counter, and those are two base units, and you can sandwich between them. And in this particular instance, I've got a 5312A ASCII interface, but I know you do get some other middle units, and they kind of just snap together. They've got these pull levers here which allow you to slide them together and clamp them down. Now, Thomas did say that these three units here are working, or appear to be working. The problem is in this top unit here, the actual display part and power supply part. And from what he says, the power supply rails are all okay, but a couple of the chips inside are actually getting a little bit warm, so we'll take a look at that. So let me put these units aside for the moment, but we will get back to them hopefully if we can get this top unit working, and we'll actually try it out, but we'll concentrate our efforts at the moment on the actual top unit, the display part. Now if I turn it round, you can actually see, yep, indeed it's got an IEC connector on the back and a fuse. And looking at the underside, you've got this large connector here which allows it to interface to the module directly below it, whether that's the middle unit or the base unit. And over here we've got the line voltage selector switch, currently set to 230 volts, and an internal external oscillator switch there, because you've got a BNC in the back there, which is your external oscillator option input. So I think what we'll do is, before I actually power it up, I am actually going to try and disassemble it to some degree so that we can take a look at those ICs that are apparently heating up. He did give me the numbers of them, so I should be able to spot them on the other side of the board. Wow, just one screw seems to hold it all together. Wow, isn't that nice? Let's take a look at that. It's an old board, but yeah, that's rather nice. So we've got a transformer at the bottom. Looks like we've got an internal oscillator here, and what appears to be the power supply, part of the power supply circuit round about here. And we've got a few ICs in sockets, definitely old school. With some of the date codes appear to be 78. Now the manuals I've got for it are stamped 1977, so this must be a slightly later one. And we've got a little plug-in board here. I'm not sure what that is. It's got some writing on it, but I can't quite see because of the oscillator there. Series 1428 written on it, and that just looks like it just plugs in. So let me check Thomas's email. Let me see if I can spot the two ICs that you mentioned that were heating up. Right, you mentioned U1 and U14. Well, this is U1 over here, which is a hex decade counter. Definitely in an old school package there. And up here, he's already removed this one. This is U14. And this was a BCD to 7 segment decoder, obviously for the front panel. Now, given that we have two ICs that were getting hot, and obviously faulty by the sounds of it, I would suspect there was a power supply problem. However, Thomas did say there isn't, but I'll check that. But I'd also say that these early 7.4 series ICs didn't have as good protection on the I/O pins on them as the later versions of the 7.4 series ICs. So it's quite reasonable that we could have two ICs just developing a fault and have no actual power supply problem, etc. But we'll check that out. Well, lovely manuals for this old kit. We've got some great schematic diagrams and a parts list as well, so that's great. So we've got over here, here's U14. Let me zoom in on that. And there's that BCD 7 segment decoder. You got ABCD coming in, and it's directly driving right across all the 7 segment LEDs on the display. And here's the hex decade counter U1. Not exactly sure what it's doing, but it just seems to be part of the logic in and around the functions of the actual unit itself. So I'll go away and look up the parts list in the manual and see if I can obtain some of these 7.4 series logic ICs. I'm presuming this one is. I know that the BCD 7 segment decoder IC is a 7446 or a 74LS46, depending on the exact spec that you want. But the hex decade counter, I'm not too sure. I've got the pin out here, so obviously I can see if I can relate that to perhaps a more modern device, because it doesn't have a modern 7.4 series part number in the actual parts list itself. Well, for U14 I have managed to find some original 7446 7.4 series ICs, so I've got a batch of 5 new old stock here, so I can replace that one. Now U1 was a little bit harder to find. I did manage to find a replacement, an identical chip from back in the day, because there is no direct replacement 7.4 series type. And that's because this chip actually has a negative as well as a positive supply, so it's a little bit special from back in the day. But first things first, I'm going to remove U1, I'm going to tidy up the pads around U14, and then we're going to power up before I put in the new ICs. I want to make sure that the power supply is okay. Okay, so I've fitted 2 IC sockets there, all ready for power up. As I said, I'm not going to fit the new ICs just yet. We're going to power up and check out the power supply. And very conveniently, let me just zoom in. On the edge of the board here, looks like we've got the power supply rails. +5, -5, +17 and -17. And I think maybe across here, not sure, +3.5 maybe. Well, we'll check all that out. So let me get it set up, let's get power into it and measure those supply rails. Okay, here we go, ready for a power up. The AC coming in. You've got the IEC connector here, you've got a couple of inductors there coming on to the fuse and the AC selection switch, and you've got a couple of, looks like Y-class capacitors there on the AC input, and then you've got the transformer here. You've got the 2 primary windings here, obviously for selection of 115 230, and you've got the AC output, the secondary on that transformer, the 2 green wires going away off here over towards this bridge rectifier, 4 diodes there, and I presume this is the main bulk cap there. So let's power it up and let's just quickly measure and see if we've got any DC supplies on those points I mentioned earlier. So I've got my meter all hooked up. So I'm assuming that the chassis is connected to 0 volts in the system, because this BNC connector, it doesn't have any separate cable, it's just earthed onto this bracket here. So let's just check and see if we've got a +5 volts. I've got the switch in the on position there, so if I just lean over and put on my AC, I've got nothing on the front obviously, and no DC supplies at all. So let's just check and see if we've got a secondary over there. I'll turn the board around for better access. Let's measure this secondary. Good contact there. 2.1 volts. That doesn't look right. 22 volts. A better connection now. Now let's try across this capacitor. I haven't looked at the circuit diagram yet to find out. Nothing across that. So let me check the diagram. Let's see how this bridge rectifier and the capacitors and the supplies are all set up. Well, as I know nothing about this system, here's the AC input coming in, transformer, bridge rectifier, there's that 1 mega ohm resistor and the 4.7 nanofarad capacitor across it, and that 22 volts DC just goes along here and onto the connector, and you can see here 22 volts, not sure if you can read that, so small. So yeah, indeed, I think we need the rest of the system connected possibly in order to get this thing up and running. Okay, so what I've done is I've managed to hook up the top board onto one of the base units here. I'm thinking that possibly there's some required circuitry in this base unit that allow me to get power up onto the top part of this top board, the display board. So I've hooked it up, I'm ready for a power on, so let's see what happens. I've left the two ICs out at the moment. I was going to put them in, but nah, let's check the power supplies first. So I've left them out at the moment. So yes, and we've got something. So before I go any further, let's just check those supply rails on the side of that board there. So plus 5 volts, yep. Minus 5.2, yep, close enough. Plus 17.5, close enough. And minus 17.5, so I'm getting the supply rails that I need, and we've obviously got something on the display. In fact, we've got something flashing down there, so it looks like we're up and running. So I think I'll go and fit those two ICs now, and let's take it for there. So switch it off. Okay, that's the two ICs fitted. Power back on again. Right, and let's power her up. And yes, we've got something on the display. So let me just check those voltages again. 5 volts, yep. Minus 5 volts, yep. Plus 17, yep. Minus 17. How about that plus 3.5 that I spotted? Yep, 3.6 volts, that'll do. So it looks like we've got power. And none of the ICs seem to be heating up at all. Yeah. Looks like we're up and running. So let's see if we can actually get this thing to work. So let me hook up my signal generator and let's see if we can actually get something happening on the display. Well, I don't seem to be getting anywhere with this base unit. I mean, it's full of 8s most of the time, and then every now and then you get something on the display, but I can't seem to get the level to set on channel A. I've tried channel B and I can get the level to set, get the light to come on by adjusting the level adjustment knob, but other than that, you know, you got some digits there and it just seems to flash around, but not seem to be getting anywhere no matter what I do. So I'm going to try the other base unit, the other timer counter, and let's see how we get on with that. Well, I can't get this other base unit to do anything either, so I'm beginning to suspect we've still got a problem with this top display board. So let's take a look at the circuit diagram for that. So via the big connector underneath, the signals that drive the display come through this part of the circuitry here. You've got a mux, you've got a 4-bit binary counter, you've got a little oscillator, and that comes into a 3 to 8 line decoder for the digit drive. I've got a bunch of PNP transistors here, and also a BCD 7-segment decoder. This is U14. This is a chip I replaced, and that produces the actual segment drive A to G. So the first thing I'm going to do, I'm going to check and see if we're getting ABCD here, and also ABCD on the inputs to U14 and U7. Okay, on to U14 first, which is the segment drive. So pins 1, 2, 6 and 7 are the ABCD inputs. And yeah, that's looking okay. Pin 2 is B, a little bit lower in voltage, but it should be okay. 3, 4, 5, 6. Yeah, that looks fine. Oh. Dodgy connection there. Nope, that's fine as well. So the segment drive looks okay, and that's reflected on display because we weren't missing complete rows of segments or anything like that, so that kind of makes sense there. And next is U7, which is here, so let's just check pins 13, 14 and 15. I don't need to check pin 12 because it's grounded. There's 15. That looks okay. 14. Yep. 13. And pin 12 is grounded. So look, we've got valid data there. Let's just check the output of that 3 to 8 line decoder. Pin 1. Of course, remember this is the digit drive. Pin 2, 3, 4, 5, 6, 7. Yeah, they're all working. Looks like that's okay. Well, looks like I've found something anyway. I've got the counter in a mode where it's counting up at the rate adjusted by this front panel pot here. And if I just get it at a reasonable speed, you can see that it's counting up here, and every now and then you can see that segment G, that's the horizontal one across the middle there, is always on. Let me just slow it down a little bit further. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. You can see it's always on. And I suspect that's what's happening with the rest of them. And that's segment G. And if I look at segment G on the scope, it's low all the time. And let's look at one of the other segments just for information. And that's what it should be looking like. But yeah, segment G is low all the time, and that's coming from U14. That was one of the ICs that we replaced. And well, having a look actually at pin 5, that should be 5 volts. That's an input to U14. And according to schematic, that should be at plus 5 volts. I'm not sure what the pin is yet, but it's certainly not at 5 volts. Here's 5 volts here. And pin 5, well, it's barely under 2 volts there. And definitely on the schematic, that's meant to be tied to 5 volts. So I've just been looking at pin 5 on the circuit board, and there's no track on the underside. And actually I can't see, I've lifted the chip and I can't see a track coming away from pin 5 on the top side. Now the IC socket isn't away. I think that input's floating, and that's the ripple blanking input on that BCD 7 segment decoder. So I'm actually going to go ahead now and tie it to 5 volts, and let's see what happens. Well, that didn't help, so the fault's somewhere else, but I'll leave that link in because it certainly should be tied to plus 5 volts. But the next thing I found, I've gone back to pin 14, the output of that 7 segment decoder, and segment G is low all the time. Now I don't think there'll be a problem with the display pulling it down or anything like that, but pin 14 does have some other logic attached to it. The output can actually be pulled low by this transistor here, which is driven by U15, and U15 is the output from a NAND gate. So let's put the scope on that and have a look. So there's pin 14 again, and as you can see it's low all the time. And let's look at the output from the NAND gate driving that NPN transistor, pin 6. There it is there, it's sitting at about, what, 1 volt? And the input, the inputs look fairly reasonable, but the output is just stuck there at 1 volt. So either the IC's not working, or this transistor here, this NPN transistor's got a fault. So I think I'll just pull that transistor, easy enough to do, and I'll see if it's working externally. Well, Looks like we've got something going on now. What I've actually done is I've removed the transistor, checked it externally, and it's fine. And measuring pin 6 on that NAND gate now, it's high. The output's high all the time. So it was driving that transistor on, and you can see the NAND gate driving the transistor, turning it on, and therefore pulling that line low. So with the transistor removed, I've now got no interference on that segment G. And as you can see, I've got a nice display now. Still haven't tested it in terms of functionality, so the problem seems to be lying at the output from that NAND gate or further back into the circuitry. Something's driving that pin 6 on that NAND gate high when it shouldn't be. So I was just looking at one of the other NAND gates on that package, and pin 8 is the output and 9 and 10 are the inputs. And looking at pins 10, that's high all the time. Looking at pin 8, that's high all the time. So if it's a NAND, the output should be low. But look at that, it's high as well. So given that we've got a problem with gate number 2, gate number 3 looks like it's got problems as well. So I think actually I'll go and change out that IC. Well, actually, it's a little bit more complicated than that. You might be asking, why have we got a transistor here driving segment G low? Well, actually, it makes total sense. That's for the negative sign. Segment G is used for the negative, the minus sign. And if you look a little bit closer, those two NAND gates, the outputs are actually tied together and driving the base of that NPN transistor. And the reason you can do that is because this particular NAND gate has open collector outputs. So any one of those NAND gates, or indeed the line that comes from off screen here, this line coming up here, comes from an IC, and that line is marked high for minus sign. So the minus sign is driven up here and onto that NPN transistor there. And you've probably got some sort of inhibit or some other functionality here that can help control that negative sign and the drive for the segment G. So here's a little diagram very similar to what's going on here. You've got multiple NAND gates there, each with open collector outputs, and you've got the pull-up resistor there to the plus 5 volt supply. And here's it drawn schematically. You can see the 3 NPN transistors on the output, and you can see that any one of those gates can take control of this line here. One or more of those transistors can turn on and pull it down to 0 volts. If all the transistors are off, then the pull-up resistor pulls it up to 5 volts. So now that I know segment G is on all the time, confusing the display a little. And in addition, I'm not sure if those leading zeros should be there or not. Maybe there's a problem there as well. I'm not too sure. Let's look beyond that and see if we can see some readings on the display. I've got my signal generator hooked up, so let's power it up and let's take a look. I've got it now in auto mode here. So let's see. Well, okay, so 00002520. Well, actually, I've got the signal generator running at 2.5 kilohertz. So that is actually working. So let me dial up something else. There's 4.7 kilohertz. 4, yep, 7. So it's reading slightly high. That'll be the internal oscillator. Maybe that'll come down when it warms up a bit. But it does actually look like it's running. Well, managed to get my hands on a couple of 74L03. I've been looking at the date code 1973. Okay, so let's remove the faulty one, or the suspected faulty one, and let's put one of these in its place and see if the display works. There's that one removed. And I'll put in the older of the two that I've got. Well, they're definitely second hand. Solder all over the legs, but we'll try anyway. There we go. Let's try that. And yes! That's what it was. Let me put on the signal generator. And I've got it set to 1.5 kilohertz, and then we're getting exactly that. So let's screw up and see what we get. 4.2. Yep. And how about 25 megahertz? Yes, that's looking like it's working. And how about both inputs running? I've got my signal generator running at 25 kilohertz on both A and B, and I'm frequency A divided by B, and I'm getting exactly one on the display. Perfect. And setting channel B at 12.5 kilohertz 2. So it looks like so far so good, it's working. So what I think I'll do now is I'm going to box this one back up because I'm quite keen to try that ASCII interface. I'm presuming it just outputs an ASCII serial stream, no idea, but let's put this one back together and see how we go. And there's the stack put together. Actually, it's quite nice. The serial interface, the ASCII interface, actually has a carrying handle built in. Yep, one on each side, and I think it looks rather good for back in the day anyway, the mid-70s or whatever. But actually I don't think I'm going to be able to test the ASCII interface. I do have a talk light on, but if I just turn it round, let me just turn it off and turn it round, and you will see it's got a rather unique connector here, a little bit like the interface connectors inside, a smaller version. So, you know, I'm not going to probe around there and try and see if we've got a signal. It's probably a serial interface where we're needing to set up DTR, DSR and all that sort of thing for the comms, I would presume, and setting up the address here. So I think we'll just assume it's working. But at the end of the day, I think we've got it up and running. Not sure what I'm going to do with it. I'm just going to put it on the workbench for a while anyway, and you never know, it might get used every now and then. So thanks for watching, and don't forget to like and subscribe. It really does help the channel grow, and if you want to help more directly, then you can always donate via PayPal or Patreon in the links below. Plenty more repair videos on my channel, check them out, and thanks for watching.